So look at the one problem that he didn't help walk you through. Which problem is it?
Number
An
15.
evil math teacher.
The evil math teacher problem.
Yes.
So, an evil math teacher is giving you a test worth 150 points. There are 46 questions on the test. Some are worth 3 points each, while the rest are worth 5 points each. How many of each type of question are on the test? So, what do you already know needs to go in my chart at the top? Total, where?
In the last box.
Okay. What else do y'all know?
Wow, I'm retarded. I did
Abraham did it on the wrong box.
Yeah, I did the question. I thought we were going in order, so I just did it in order.
You did it on the other box.
Then you can draw arrows between your
Yeah,
boxes
draw
or
arrows to
something.
make sure they're like.
Okay, so what totals do you know?
46 questions.
46 questions. So if we know there's 46, what's my label over here going to be for that?
Questions.
Questions. Okay. Then what's another total?
We got 150 points.
150 points. So points is going to go right here. So then what?
You also have the questions are 5 points each.
Okay, so we've got one question type. That's 5 points. What else? What other type of question do we have?
We have a 3 point or 3
Mhm.
point question.
So 3 point questions. So what variable would we use if there's not a good letter that we could use? I mean, like we can use 3 or 5 as our variable because those are numbers. And they're talking about the same thing. So what variables would we use?
X.
X and
Y.
I missed a marker. Oh, darn it. So we've got X and Y. So both of them are going to be X and Y.
And Y.
So where is my 3 and 5 going to go? Which group? With the questions or with the points?
With the points.
With the points because they're 3 points each. So 3 and 5. Here's another clue about that. So notice that 46 is less than 150. So if you are not sure, most likely any multiplication is going to go with the bigger number, the bigger total, right? Okay, Abraham, covering your eyes, that doesn't help. Your eyes are not what breathes.
Oh, I thought they were.
At least not for human beings. Now, if you're an alien, we might have some other issues like outer space alien or something, and they might breathe through their eyes. I'm not sure, but we don't. Okay. So then we got to add our plus signs and our equal signs, right?
Mm-hmm.
Then go ahead and rewrite them. So x plus y equals 46.
Now I know how to write it out. I just don't know how to write it out.
3x plus 5y equals 150. What do you mean you don't know how to write it out?
Like, I didn't know how to write out the problem. I didn't know how he got the number, like how he wrote it out. I know how to put the numbers down, but then how you wrote it out, like you showed me, like I just figured out.
Okay, so what do I need in front of this x and this y right here?
One.
A 1, so that we remember that there's a 1 there. Okay, will anything cancel right away?
No.
No. So what am I going to have to do? Nope. I've got to cancel. I mean, I need something to cancel, so I'm going to force them to cancel. Okay, so I need to force them to cancel. Okay,
One negative,
so which one's which? Which one's gonna go on top?
3.
The 3.
The 3, and which one's gonna go on bottom?
The 1.
Negative
-1.
1. Okay. So 1x times 3 gives me
3.
3x.
Wait,
1y
wait,
times
what?
3.
Oh,
Hmm?
never mind.
1y times 3 is?
3.
And 46 times 3 is?
46 times 3 is
138.
Mhm. Okay. Then we've got negative 1 times 3x is?
negative 1 times 2 is negative 3.
So multiplying by negative 1 just changes the signs of everything, right? So this positive 5y would become a negative 5y, and this positive 150 would become a negative 150. At this point, this is just a big addition problem. We're just combining all of our like terms. So 3x plus negative 3x, or 3x minus 3x is 0. They cancel. 3y minus 5y is
3y minus 5y is negative 2.
negative 2y. 138 minus 150?
22. Negative 22. Oh, wait, what?
Negative 12.
No, I wasn't.
Okay.
No, I wasn't.
So then divide by negative 2, which gives me y equals 6. What is that 6 talking about?
The number of
Y. So Y is 6.
And what's my y?
The
Representing.
5 points.
5 points. So there are 6 5-point problems or questions, right? Okay, am I done?
No.
No, now I gotta
we can plug
substitute it
in, substitution.
again. So x plus y equals 46. So if my y is 6, then how many does that leave to be x?
1. Oh, 4. D.
40. And there's 40 what type of problems?
40 word problems.
3
No,
points.
no, 3-point problems.
3-point problems. Okay. 33-point problems. So that's how that problem gets done. Okay. Now I'm going to go ahead and pass back the quizzes, and we're going to go over them. That's why I had to send Jordan to go take his. So we're going to go over the quizzes together, and then we will talk about your assignment.
Wrong.
Okay. Lots of people did. Okay. So right here. So I'm repeating what I said because I forgot to unpause it for the online people. Okay, so 3 ways to solve a system. And then there was a hint that said, look at the next problems on this page. That's why I drew these arrows here. So solve by graphing, solve by substitution, solve by elimination down here. So that was your hint. If you still didn't get it after that hint, then I don't know what to tell you. But there's 3 ways to solve systems of equations. Those are them. There's one other way, but you won't learn how to do that until Algebra 2, which is called matrices. Okay. So in this one right here, solving by graphing, okay, use Desmos, but accuracy is very important. Okay. Accuracy is very important. So make sure that you're using the rise over the run to count your slope as much as possible. Some people graphed really closely, but because they used Desmos or they used the graphing calculator or something, and they only did the x-intercept right here, and so it didn't actually get them where they needed to be, so they were off a little bit somewhere up here, but not at 3.3. Okay, so use the points that are actually on the grid when you're graphing, the nice even grid points, okay, to graph. So the solution when you're graphing, it is where they cross. Okay? Where they cross is the solution. Okay, it's because that's the point that works for both of them. Then on this next one, okay, this one is solved by substitution. Okay. So notice that I put a note here. It said x is the same as 3y plus 2. So you're going to replace the x with the 3y plus 2. So you only have one variable to solve for. So once you replace it, you should only have one variable left. If you end up having two variables, once you substitute it in the wrong spot. Okay, so that should be a red flag. Red flag that you have two different variables after you substitute. Okay. So I want to illustrate these with algebra tiles. This one, just to give you a visual of what happens when you're substituting. So that algebra tiles that I just showed you is showing the work that I did here algebraically. We had to replace two x's with this. That's why I distributed this 2, giving me 6 positive y's and 4 positive 1's. Okay? And I already had the 3 negative y's on the same side, so those canceled. Some of them canceled, leaving me only 3y. Then I had to move my 4 over. That's where I got negative 4 added to that other side, giving me negative 6. Then I divided them into 3 groups, which gave me negative 2. So then this negative 2 gets substituted back in, right? 3 times negative 2 is negative 6, plus 2 is negative 4. So there's my coordinate. Okay, a solution is a coordinate. Then I've got problem number 4. Okay, this was already set up where it would eliminate. So you're making a big addition problem. So add everything together, add all your like terms together. So these 3 positive x's and 3 negative x's cancel. 5 plus 1, this was one of the mistakes that I saw, where that they did 5 plus 0 because they forgot to write their 1 there and got 5, so then they ended up with a fraction over here. Okay, so you should have got 6y equals 6. Divide both sides by 6. Here's the other big mistake I saw. 6 divided by 6 is 1, not 0. Okay, so y equals 1. Then when I substitute it in, some of you, I substituted the top one, some I substituted the bottom one, so you might have different work on your paper than this. But plug in 1, still should have given you the same thing, which x equals 3 divided by 3, which is 1 as well. So 1, 1 was your answer for number 4.
Mm-hmm.
Problem number 5 was not where that you could eliminate right away. So you had to multiply just like we did in that test problem, the test question problem we talked about at the beginning, right? That other example. So 1 multiplied by 1 on top, because I took the 1 that was in front of this x, multiplied by 2 on bottom, but they are both positive, so I needed to change the sign so that something would cancel. So 2x minus 2x cancels. Don't forget this 1. Again, that was one of the biggest mistakes I saw. They did all their steps right and whatever, and because they forgot this 1 at the very beginning, they messed it up. So 1y minus 4y is negative 3y. Divide by negative 3 on both sides, and you get y equals 2. The other thing I saw was the sign being wrong, where only one ended up with a negative, or they just reduced wrong and kept the 2 negatives. So it was positive 2. Substituted in, and we got 2 times 2 is 4, and x plus 4 equals 5, so x equals 1. And some papers I forgot this step on because I felt like it was obvious to know that 1 plus 4 equals 5. So the solution there was 1, 2. Then if we look at the back, okay, this was what was on the very front of that foldable that we did in class the day before the quiz, when we talked about graphing. And we talked about what these type of solutions look like. One solution is just two lines that cross at some point. Your two lines could have been any kind of lines. They just had to cross at one point. Okay, so your description, any two lines that cross or intersect at one point. Okay, they have to have different slopes. Okay, so if that your two lines have different slopes, they will have a solution. If they have different slopes, they will have a solution. The no solution and the infinite solution, both of these, okay, have the same slope. Okay, one is parallel lines, so they could have been any kind of parallel line showing that they didn't ever intersected. Okay, parallel lines was the key word in the description here. Same slope, different y-intercept. Infinite solutions. They're exactly the same line, so they have the same slope, but they also have the same y-intercept. The vocabulary word was collinear, right? You didn't have to say that, but you had to say something of those sorts. They intersect infinite times. Okay, they intersect an infinite number of times. I'm trying to get through this so I can give you your assignment, because yes, you have an assignment.
Yeah, cool.
Okay, so no solution for this one because everything cancels out and you get 0. 0 equals 22. Okay, that's a lie, which means it's no solution. Down here at the bottom, I was just trying to get to see if you could use these pictures to come up with the equation looking like algebra. Okay, so the first variable here, okay, notice underneath it says, what letter will you use to represent your first variable and what will it represent? So I chose P for pies, okay? You could use X for pies, but you had to tell me what it was talking about too. You couldn't just give me a letter. The same thing here for your variable 2. I chose C for cakes because it chose Y for cakes. But then here was my equations because I had 2 pies, so 2P plus 3 cakes, so 3C equal a total of this. Same thing here, 3 pies equals 1 cake and is 29.50. So your assignment that I'm going to hand to you is this one. Okay, it's all word problems. I want you to try to solve 5 out of the 8. But at the very least, because we didn't have any time in class, the very least I want you to get all 8 of them set up. To the best of your ability, set up all 8 of them, even if you don't have time to solve them, okay? And you can also use, you don't have to draw the, I'll take them back up. You don't have to draw the outside box. You can just draw the lines like this without the boxes around it if you want to save you some time when you're making your grids to set things up. Okay. So turn your